So what do the graphs of these functions look like? Well, they're going to have an asymptote on the x-axis, y equals 0. And they're going to go through the point 0, 1. This is exponential growth. That's a is larger than 1. That's the a is in the interval 1 to infinity, not including 1. A greater than 1, exponential growth. Exponential decay is when a is between 0 and 1. A in that interval 0 to 1 with parentheses around it, right? That's exponential decay. And you can see that makes sense. If you read these graphs left to right, which most people would, you can see why they're called what they are. Notice that either type of exponential function is 1 to 1. So that means that they have inverse functions, which we call logarithms, which we'll do in a later section. So f of x equals a to the x. If f of x is a to the x, then f inverse of x is log base a of x. That's how we read that, log base a of x. And that's just an aside. We'll see logarithms later. Since exponential functions are 1 to 1, that tells us that if a to the x equals a to the b, then x must be equal to b. Okay, that's what 1 to 1 means. If the outputs are the same, then the inputs are the same. So x equals b. So we can use this to solve some very simple exponential functions. And that's all we're doing at this point. More complicated exponential functions you have to solve using logarithms, and we haven't done those yet. So we're just sticking with these simple ones at this point. So for example, if we have 2 to the x equals 8, the way to solve this is to write 8 as a power of 2 and then equate the two exponents, right? So if you have the same base, then you can equate the two exponents. So 2 to the x equals 2 cubed, so x equals 3. It's that simple, okay? It's another example. 1/2 to the x squared minus 2 power equals 2. Well, I want to write 2 as a power of 1/2. Or I could write the 1/2 as a power of 2, either way. But I wrote 2 is the reciprocal of 1/2. So it's 1/2 the whole thing to the minus 1 power. So now the bases are the same. I can set the exponents equal, and I get x squared minus 2 equals minus 1. And then solve that for x. The easiest way being to add 2 to both sides, or move that minus 2 term to the right, get plus 2. 2 minus 1 is 1. And then x is plus or minus 1. And if you plug those in, you'll see that it works. If you plug those into the original up here, you'll get 1/2 to the minus 1, which is 2. And you can check it on your calculator if you're not confident.